Hey guys, welcome back to my CCNA 200-301 course. Patrice is here, and in this video we are going to review some routing basics together. Are you ready? Let's get started. As I mentioned before, when we have different IP subnets, either IP version 4 or IP version 6, we need a router to provide connectivity between different IP subnets. The router can be a specific device that has been designed for this purpose, but also the functionality, the routing functionality can be incorporated in other devices as well. For example, Cisco has multi-layer switches or MLS, which are basically switches, which means they are operating in layer 2 and they can provide switching. But also they are able to do routing as well. So they can operate in layer 3 too. So we call them multi-layer switches. But feature-wise, they might not be able to compete with the routers. So if you want to choose the right device for your network, first you need to list your requirements and then check which device would be able to provide all of those features you need for your network, then purchase that device. Routers operate based on the routing table. For the sake of 200-301 examination, you need 4 fields of this table: prefix, subnet mask, next hop, and outgoing interface. For example, 192.168.0.0 with subnet mask 255.255.255.0. Next hop is 172.16.0.1 and the outgoing interface is gigabit Ethernet 0/1. This entry in the routing table is called a route and simply means that, hey router, if you receive a packet and when you disassemble it and checking the IP header and the destination IP address is something in this network, which means that something between 192.168.0.1 to 254, then your next hop is this address. Next hop means next router, and this is the IP address of our next router. And this router, this next router, is connected to this interface. So when you want to reassemble the data and sends it out, it has to go out of gigabit Ethernet 0/1. So you need to do the right encapsulation. In this case, it's an Ethernet frame. If you remember, when we talked about IP address, I told you cannot use 2 IP addresses. One of them is the one that has all zeros in the host ID part, and that is reserved for the network address. And this is where we use that specific address. Instead of adding individual entries per IP, we add the whole subnet, which covers all of those IP addresses. You need to know, there are 2 important things about the routers in my mind. First of all, routers are not responsible for end-to-end delivery, which means that they only know about the next hop. And if you have multiple routers from point A to point B, each of these routers is only responsible to send the packet to the next hop, next hop, next hop, next hop. It is exactly like the posting services. When you want to send an envelope from your country to another country, for example, this is happening like this. You send it to your local post office. Your local post office will send it to the central post office. Central post office of your country will send it to the central post of the next, the destination country, and so on and so forth. So each hop, each router is only responsible for the next router. And eventually, all of them will do the end-to-end delivery if you configure your routers properly. The next important thing is routers, in contrast to switches, they only operate based on these routes or entries. If you remember that, switches will broadcast the messages or the frames that they don't have any entry for the destination MAC address of that frame. and they will send it to all interfaces except the incoming one. But routers will not do that. Routers will drop the packets if they don't have the right entry for the destination IP address of that packet. So you need to be careful when you configure your routers. All of the routers need to know everything about all subnets if you want to have the proper delivery. A question may have come to your mind. How do these entries get populated in the routing table? Basically, there are three sources that can enter routes in the routing tables. The first one is connected routes, or we have three types of routes basically. Connected routes are the networks that are directly connected to the router. And router will populate these routes automatically as soon as you configure an IP address on an interface and that interface comes up. So, for example, if you add an IP address on a router interface like 10.0.0.1 with /24 subnet mask, as soon as this interface comes up and becomes active, a route will automatically be added to the routing table for 10.0.0.0/24, and the outgoing interface is going to be this interface that you configure the IP address on it. The second type of routes are static routes. Static routes are the routes that you, as the network administrator, add them to the routing table. So these are the manual routes that you add to the routing table. When your network is small and the number of IP subnets is not that much, static routing is a choice. But when you have a large enterprise network with hundreds of IP subnets, then static routing configuration gonna be a very cumbersome work. So you need something more dynamic. And this is where dynamic routing protocols come to the picture. So with dynamic routing protocols, these entries will be populated in the routing table via the routing protocols. And you, as the network administrator, have to configure the routing protocols properly so the right route's going to be populated in the routing tables. Dynamic routing protocols are like RIP, OSPF, EIGRP, and BGP. In the previous CCNA 203/01 course curriculums, in the topics, we had RIP, OSPF, and EIGRP, all of them for concepts and configuration. But in the recent course curriculum, we only need to know about the OSPF, which is a very nice routing protocol. Anyway, I'll be talking about OSPF in the upcoming videos. So our routes either going to be a connected route, a static route, or a route that is coming from one of these routing protocols. Alright guys, this was our today's video. In the upcoming video, I'll show you how you can configure static routes on routers. I wish you enjoyed today's video and see you in the next ones.